Now that adding our bird and using our invisible slingshot seem to be working pretty well, it is time to add actual obstacles to our scene, like blocks of wood and such, with which we can build structures to later protect the enemies we will need to hit. To be able to properly handle them in our game, we will add a custom node class for them. It will of course be added to our custom nodes group, and it will be a Cocoa Touch class. The superclass will be SK Sprite Node, and I will call the new class Block. I can then create it, and after we've exchanged the import to be sprite kit to get rid of our error, I can, right above the class, create an additional enumeration, pretty similar to our bird type enumeration, which will be called block type. This is because we will have 3 different materials our blocks can have. So for the block type enumeration with the raw value type string, I will add the cases wood, stone, and glass. Since these are the 3 graphics we have provided, and those are the ones that we're going to use in our game. Inside of the block class, I will begin by, similar to the bird class, adding a property called type, which simply specifies which type my block has. So let's add a constant called type, which will be of the new block type. Our blocks will also have a certain health, so that we can check if our bird has damaged them enough for them to be removed. We'll add this as a variable called health of type integer. Finally, we will add a damage threshold property that will specify a certain threshold of damage that our block can take before we exchange its texture for a broken one, signalizing to the user that this block is already damaged pretty badly. This property can also be a constant, since it won't change like the health, and it will of course also be an integer. We do now need an initializer for our block class, which I'm now going to add. It will only have one parameter type of the type block type, since our other 2 properties will just be set depending on which type we have. Before we add the content of the initializer, I will add the required initializer to fix this error here. Alright, in the initializer, I will first of all have to set all the values for my 3 properties. I can start with the type, which is the one that we get passed here. So let's write self.type and set it to type. For the properties health and damage threshold, we will now check this type and set them appropriately. I can do so by writing a switch statement for my pass type. Inside of the switch, I will then add the cases for all 3 possible values. Beginning with the case wood, and if this is the case, I will set the health property to, let's say, 200. Next is the case stone. Stone should be tougher than wood, obviously, so we will set health to 500. And finally, the case glass, which will be our weakest material, and therefore we will set the health to just 50. I can delete the default case, since we did handle all possible enumeration cases here. Our damage threshold property will depend on the maximum health of the node. So I can just write damage threshold and set it to health divided by 2, which will set the threshold to exactly half of our health. Finally, I will have to call the superclass initializer, so a designated initializer of the SK Sprite Node class. I will choose the initializer with texture, color, and size. For the texture, I will pass nil. The color will be clear, and the size will be cgsize.0. Now you might be wondering how this can make any sense, since it will be an invisible node with no size. But don't worry, we'll set the actual properties later on in the game scene as we actually add the blocks to our scene. But before we do that, and also edit our SKS file where we can easily build our levels visually, I want to add one custom method to my block class. And that will be a method that should create the physics body for the block. The method will be called physics body and it will not have any parameters. Inside, I want to initialize the node's physics body property with an SK physics body instance. And I will once more use the initializer with rectangle of size. And obviously just pass size, so the size of the block node itself. I will then set physicsBody.isDynamic to true, so that our blocks can be impacted by the bird and are also affected by gravity. And also physicsBody.categoryBitMask, which we will naturally set to physicsCategory.block. We should probably also define the contact test and collision bit masks, starting with physicsBody.contact test bit mask will be set to physicsCategory.all to check contact with all other physics bodies in our game. PhysicsBody.collision bit mask will also be set to physicsCategory.all, since the blocks should just collide with all other elements in our scene. And we also want to check any contacts that happen to react accordingly later on. This concludes our block node class for now. And we now have to think about how we could add them to our actual scene. To do so, I'll begin by going into my game scene. Let's zoom out a little here first. And I now want to add kind of a placeholder node here, which I can later in my code reference and then add a block node exactly of the same size where the placeholder is. So I'll just use an ordinary color sprite for my placeholder. So let's just drag one in. And I can then just change its size how I want and reposition it. So let's maybe put it here. Like I said, this will not be the actual node shown in the game later. It is just a placeholder that I can later in the game scene query for and then replace it with a proper block node. To be able to actually query and access my placeholder nodes from our code, I will have to name the placeholder in the SKS file. And I'll just use the names wood, stone, or glass, so that we know which block we should replace our placeholder with. For my one demo node here, I'll just call it wood. Other than that, we don't really have to change much here. The node is colored red, which absolutely doesn't matter since the placeholder won't be visible at all. But for editing, it is nice to actually see where the node is and how big it is. What I do need to change for this node is adding it as a child node to my tilemap node, since the map node's children is what we are going to search for the placeholders. And that's it for the scene editor. And we can go back to my gamescene.swift file. I want to add the block nodes in my setup level method, which should make sense. At least I think so. So right after adding our camera, I will add a for loop to iterate over the child nodes of our map and see if we can find any placeholders we need to replace. So I'll write for child in mapNode.children, which will return all the child nodes of the tilemap. I do now, however, need to check if the returned node in each iteration is a sprite node, and if it is a placeholder node for a block. I'll begin by writing if let child is child as SK's sprite node, so that we only get the sprite nodes. And if it is a sprite node, I will need its name. Since the name property is optional, we will use a guard statement by writing guard let name is child's name. Now this is really important. In the else part of this guard, I now do not want to write a return statement, as we often did, Because if I do add a return statement here, any node that is found without a name by this loop will trigger abortion of the complete setup level method. So we won't add the scene's physics body and we won't spawn a bird, and that's obviously not what we want. All I want to do here is skip this iteration and check the next node. Therefore, I will not write return, but continue. This keyword just skips the current iteration and starts the next one for our for loop. If we do get a valid name, I will have to check its name, and if it is either wood, stone, or glass, meaning we would have an actual placeholder node for our blocks here. To achieve this, I can write if, and then check if the array with the strings wood, stone, and glass does not contain the name that we just found. If it isn't contained, I will again use the continue keyword to skip the iteration, since this is obviously not a placeholder node, so we don't have to replace it with a block. I now have to perform a final safety check, since I now need a block type depending on the name of the placeholder. The raw value initializer we are now going to use will only return an optional block type instance. So I will write guard let type is block type initialized with the raw value name. If this for whatever reason does not give us a valid type, I will again continue in the else part to move on to the next iteration. If we get our type, however, we have all the requirements set to initialize a new block node that I can then add to my scene where my placeholder is in the scene editor. I can define a constant called block as a new block instance initialized with the type we just got. I can then begin setting the properties of our block, just like I said we would do. Let's begin with block.size, which will be set to child.size, so that our new block is exactly as big as the placeholder in the scene editor. Next is block.position, which obviously will be set to child.position to position the block right on the placeholder. Block.color will now just be statically set to UIColor.brown. We will obviously change this later to be more dynamic, but for our wood block, we've just added it here, and it should be enough to demonstrate that this mechanism works. I can then call block.createPhysicsBody to add the physics body for our newly created block. And finally, use mapNode.addChild to add the block to our tile map. I now also want to hide my placeholder node, since it is not actually needed in the game, except for us to work in the scene editor to plan and structure our blocks in a level. Therefore, I will just write child.color and set it to a UIColor.clear. You could of course also remove the child, but setting its color to transparent should also work. And this should be it. We should now already show our block in the scene. However, we do also want to make sure that the block is always rendered above our background as well as map. So we are now going to use Z positions in our game. To manage our Z positions properly, I will go into my configurations file, where I will add a new struct to hold all of my Z positions, very similar to our physics category struct. Inside, I will begin with two constants. One is a static constant called background of type CGFloat, which we need for the Z position, and it will get the value 0. We do not need the background one for now, but it makes sense to have it as low as possible and then have obstacles at 1, which will position them or place them above the background. We can then go back to the game scene, and right before creating the physics body, I will set block.zPosition to zPosition.obstacles. This way, our block should always be visible. Let's run the app together and see if all of this effort was worth it and we can see the brown block. And maybe, if we're lucky, we can even interact with it already. If I zoom out, I can see my brown node here. I can even launch my bird at it, and we can see that the collision of our physics bodies is already looking pretty cool, and we can throw the block over. Since we fixed is setting our game state to ready after we add a new bird, I can now also see that we can launch the next bird and continue the game until I have no more birds left. So this is already working perfectly.